Hi, welcome to In 5 Minutes. Next is a common emitter NPN transistor with RE. Which type of transistor NPN? How to identify? Arrow is always from P to N. So NPN is the transistor. Now we don't have any capacitor connected in parallel with RE. So we can call it is unbypassed RE. Now the question is, for VA equals to infinity, determine the small signal voltage gain. That means we need to find AVS when VA is infinity. VA is infinity implies what? VA equals to infinity implies that RO is infinite. That means we did not consider the value of RO. RO is infinite, is nothing but open circuit. So we need not consider RO. That is VA is equal to infinite. Then determine the input resistance looking into the base of the transistor. That means they have told us to find only the value of RIB, but we can find the total resistance also. For illustration, I will find the entire resistance till the source resistance, but the question is to find only the base resistance, total resistance seen from the base, right? Now what is our first step in this? Our step 1 is draw the circuit under DC operating conditions. What are DC operating conditions? First condition is to short AC sources or remove AC sources, we can call. Next step is open circuit the capacitors. So when you do this, the circuit will look like this. We are open circuiting this capacitor, we are shorting the AC source. AC source will be short circuited. So you have the circuit which is looking like this. So for this circuit, what we need to do? We need to find VTH. How we are finding VTH? Potential divider rule, R2 upon R1 plus R2 into VCC. The values of R2, R1 and VCC are given in the question. So after solving, you should get this as 1.153 volts. Once you know VTH, we can find RTH, which is R1 parallel to R2. So R1 and R2, 75K and 250K is given in the question. So can find RTH as 57.69 kilo ohms. So you have found VTH and RTH. So once we have found VTH and RTH, we can draw the equivalent circuit showing VTH and RTH. And in this circuit, when you apply KVL to base emitter loop, what it will give you? It will give you IBQ. Again, I am writing in the short form. IBQ, total voltages in the numerator. In this loop, you have VTH and VB, two voltage sources, which will come in the numerator. VTH minus VB, two voltage sources which will come in the numerator, and total resistances which will come in the denominator are RTH, and RE is in emitter, so we need to transfer to the base, so we multiply it with 1 plus beta. So 1 plus beta into RE. So when you substitute the values, you will get IBQ as 3.47 microamperes. Once you know the value of IBQ, which value you can find out? You can find out ICQ. ICQ is beta. Beta is given as 120. So 120 into IBQ will give you ICQ as 0.417 milliampere. You know ICQ, you can find R pi. R pi is nothing but VT upon IBQ. VT is how much? 26 millivolts divided by IBQ. How much you have found? 3.47 10 raised to minus 6. So this will give you R pi. R pi is 7.48 kilo ohms. So now you can find GM also. GM is how much? ICQ upon VT. ICQ you have already found out, 0.417 milliampere. VT is 26 millivolts. So when you substitute, you will get GM as 16.03 milliampere per volt. The same thing you need to do, just need not substitute the values when the question is to derive the equations. So for derivation, how much you will write? You will write till this much. For derivation, you will just write ICQ is beta, IBQ, R pi is VT upon IBQ, and GM is ICQ upon VT. Rest all the things are similar. You just need not substitute the values given in the problem. For derivation, you need to write each and every statement. So for that, you need to write the equation for IBQ after applying KVL in the base emitter loop. Now this is the DC analysis, and for AC analysis you also require the value of RO, but since VA is given as infinity, what will be the value of RO? RO will be infinite, as I have told you. So this all values we require in AC analysis.